Well, my roaming Zoom chats weren't going well with connectivity. So. I wonder if I can I. Oh yeah, if I share. Can you see that?
Yep.
Yeah. So this is what I'm actually last week is the central pivot point for my steering, and that is a huge hex bolt nut, Allen head nut. Anyways, I found a bolt head which fit in there snugly and drilled a hole in it and shoved that onto the end of my potentiometer and put it on this kit. So yeah, that was very, uh, I did this week. So this you might remember is a waterproof industrial limit switch from a CNC designed for a CNC machine or something similar. Um, so I just got this little wooden bar on the front, which is pivoting on this point here, and a bungee holding it back. Um, so it works really well. It's really sensitive, like emergency stop thing. So yeah, my idea is just that it can, the AI can be really stupid, and if it runs into a wall or a person or a car or a polytunnel, it will just stop because this will trip the switch and cut power to the contactor. Um, uh, and the other thing is this, uh, I got this motor controller arrived and this works. So this is for my steering implement control motor. Um, yeah, and I'm pleased it didn't blow up and it controlled the speed of my electric motor. Um, the the potentiometer that controls this has 5 wires going into it, which seems a bit excessive. Um, uh, but yeah, I haven't done any kind of uh, poking at this potentiometer with my multimeter yet. Um, uh, I wasn't sure what's the easiest way to do I need to measure the voltage, and if it happens to be a 5 volt signal, then it's really easy to do with PWM or um, yeah, I just wanted your advice. What's the easiest way uh, to measure this with a multimeter in order to know what I need to do to be able to get my Arduino to control that signal line to this motor controller?
I would say that might work. Take a meter and measure it and see what you're getting on there and see if it is a nice stable voltage. And as you move it from one end to the other, does it change? Um, First of all, if you measure across the potentiometer, you know what voltage they're putting into it, and then measure from the
Yeah,
whatever the zero end is to your wiper. You can tell, it should be linear from one end to the other, and see if it does change in voltage. Otherwise, it could be
yeah,
they're using that as a resistance in their circuit, which in probably since they're using 3 wires, it looks like what I
oh,
can see is three
5.
wires on your thing there. You got yellow, black, and red. And the extra two
Yeah,
wires, it may have a switch. Does it have, if you turn it all the way down, does it click?
yeah,
Then that's probably why it's got the extra 2 wires on the thing. So it just, you can actually turn the thing off if you want to. So
right,
in your
yeah,
application, you could just set it to either open or short that so it runs all the time, and then your Arduino could just change whatever signal it has to on the thing.
yeah. So I do DC voltage, and then I put my red probe on the voltage which is going potential, and a black probe on the wiper pin,
Yes,
and I turn the knob and see what happens. Okay, great.
yes. You may not want the motor hooked up when you're doing that, but yeah, you can do that. Do you have a link for that motor driver? Do they
Yep.
have any information on it or not?
Yeah, they did have a bit. Yeah, I'll just pull that up.
That may give you a clue as to how it's wired up and what you need to do there.
Just give me a second. was going to my eBay. I haven't managed to watch the Wednesday meeting yet. I've been trying to watch them before turning up. Sorry about that. I look forward to doing that. Okay, yeah, I got it. I'll just share screen.
And be careful about showing your screen if you have any secrets that are going to pop up.
I trust you guys.
Well, it's being recorded, so you have to trust everybody.
I just trust the entire world. Okay, I don't trust the entire universe. Yeah, so this is about all the information I've got about it. Is there anything else down here? No, yeah, so it's just that. Oh yeah, it doesn't tell you anything about the potentiometer that's on there.
Yeah, I don't see anything there. Sometimes they'll give you a link to a manual, or if you know what it's called, go out and search on the internet. If they give you any kind of a brand, or back in the description, they might tell you at the top of that, they might tell you what they're calling it, and then you can go search for that on the internet.
Yeah, I can study the component itself as well and see if it's got any numbers or anything like that. And yeah, I'll do that. Yeah, so I mean, not a huge amount of progress. That's all I've done this week. Yeah, I think it's going to be a big weekend. I've got my friend. Oh, Matt, do you remember I sent you a video of my friend's robot, a guy in Anglesey?
Yeah.
And anyway, so he's coming around on Sunday. So we're going to work on it together. So hopefully he'll help me get my GPS thing set up and get all the microelectronic parts working with it. And so yeah, optimistically, I'll have more to show next week. Yeah, that's all I've got.
Hey guys, sorry I'm late.
Morning, Al.
Hey Matt. Looks like Jeff's on Alpha Centauri today.
Oh, Doug, I love your background.
Mine or Jeff's?
No, Doug's.
Yeah, Doug, what is that?
He's got
What is
Star
that?
Trek.
It's all the Star Trek ships, or a bunch of anyways. I was just gonna change it to this other one I saw last night. Find out. There it is. Pretty cool.
So what have you been working on, Doug?
Well, I got that working on 3020 for a lot. The John Deere loader tractor. Getting ready to set up for baling. A new round baler we haven't tried before. Hopefully everything works on that. A lot of maintenance and stuff. For robotics, been working on this here, which is a Android phone hooked into an Arduino, which is all then hooked into, I got a ultrasonic sensor on there for now. I've got a gimbal made out of two SG90 servos and some plastic parts. But then I got the next thing I want to do is I got one of those 180 kilogram servos on Amazon, and so I want to use that to see how well it actuates the controls on the swatter. That's kind of where I'm. One of those big honking things. I bet
Just a comment on that big RC servo, the middle pin or the red pin coming off that actually puts out 5 volts.
Okay.
The normal servo, you can put 5 volts into it to run it, but that and there's a jumper on there. You can pull the jumper off if you don't want 5 volts on there. So that block of jumpers there, you can pull one off if you don't want that. Otherwise, you can let that thing power your other electronics depending on, you don't want to draw too much off from that, but it's like the battery eliminator circuit you get on the radio control stuff.
Well, that's sweet. That could definitely be useful. You should be able to power Arduino, right?
Probably.
Like it back through. Just listening into the. This is just 12 volts, right? Hooking into your 12 volt system, or up to
Yeah.
24, I guess. But
Yeah, I think it's a 12
Here.
or 24.
once I hook it in the battery here, I'll have the 5 volt right over here. I got the one with the potentiometer on the top. I could tap into the signal lines to get a position reading, direct position reading. So that's kind of where I'm going to go next with that.
Can you give us a closer look at your gimbal?
Oh, the gimbal is just me this over. The gimbal is just I think I got a pack of these on eBay. They're basically there's a little stand I mounted on the pie box here, and it goes, so it's got this part here would go on here, swivel here, and then this one goes up and down like this. So it's and then the 2 SG90 servos are just fit into there like that and screwed in. This virtual green screen doesn't really help a lot sometimes with you're showing something like that.
Yeah, so I saw enough of it, I think. Yeah.
Okay.
Yeah, cool. Well,
Anyway, then
I had a similar.
I bought one of these at Dollar Tree, and it's for the phone on, and I want to mount this on the gimbal. That way I can position the phone whichever direction, so I get the camera image off of it using the gimbal. Attach the gimbal to this phone case, and then put the phone in the case, and then be able to move it around, position, aim it at wherever I want to aim it at. That's kind of where I was going with that. So wish me luck.
Look. So my status at the moment is had a few mechanical problems and a few, let's see. What's wrong with this picture? I won't torture you. What's wrong with this picture is there's no blue lights on these lines. What that is the USB hub that's inside of my electronics case. So you may recall I was bemoaning the fact that I was having electrical voltage issues, and I think bottom line is I've had to replace this, so I replaced it. I think when my 12 volt in was deteriorating and this was flapping back and forth probably between an acceptable and an unacceptable voltage, some chip in there that's meant to retain the state lost its ability to retain the state. So every time I would power down, I would have to open up the case and press these buttons again to get them to be powered on again. So that became quite a pain in the you-know-what. So I had to fix that. and went back to my documentation. Let's see why I won't sort of hidden behind there. So this is my documentation, and I know it doesn't sound like much to you guys, but it has been a bit of a challenge to figure out the right sequence on which to start these various launch files. And I think I've gotten the process down where I start my main launch file, then start my teleop launch file, then start the NEMA serial driver, I then start the GPS ODOM, and check to make sure I have joystick control. And then start the simulator. That's not the right simulator launch file because I made one for the real world and one for pure simulation. And I start the bag file because I wanted to save the bag file for that launch file. And so I did that, and I wasn't getting any movement, and I come to realize that my super servo has a set screw on it, and that set screw's become loose, and so even though I was sending command velocity statements to go backwards and forwards, it wasn't moving, so I've got to take the tractor apart and get some lock seal, thread lock, I forgot what you call it. Try to keep that set screw from coming undone. But I do think I have
The brand, one of the brand names for that, it's called Loctite.
Loctite. Thank you.
But if you go out and buy it at a hardware store, it'll cost you $8 for like a little 1 ounce bottle. But if you go to Harbor Freight, you can get it for like $2 for the same thing.
And I'll go to I think I have some that I ordered someplace along the way, but.
And then you also get red, or you get blue, or you get purple. And I think the blue one is called field removable. I think the red one is like a permanent type thing. So depending which one you bought, it may or may not work for you, or you may or may not ever get it apart again.
So I do have a bag file that's still on my RPi that after I got a new battery and installed one of those things like Jeff you have about turning, it's different but similar, but turning all the power off and on from the battery, and fixed my USB, but then realized my servo was dead or not functioning. I had to push the tractor back in to get it out of the rain. I do think the ODOM was moving when I pushed it back in, but I haven't rerun the bag file to confirm that. So anyway, that's where I'm at. A little bit of progress. Still working.
Right.
What else? Matt, anything to share?
Just working on the electronic box, trying to clean up my wiring bird's nest in there. I like how you have all your wires laid out nice and clean so you can track and follow them.
Can I ask a question about voltage leakage that you've triggered? Let's see if I can find my file. So I disconnected, I think I disconnected everything, and I put my voltmeter on something and it was showing a 0.5 volt. And I'm like, well, that shouldn't be. And I took the fuse out of the servo supply line and that voltage then showed 0. So I'm like, what's going on with my servo that I'm getting a 0.5 volt with the fuse in and 0 with the fuse out. Just so you have a bit of a visual. So into my super servo, trying to make this larger. Let's see, where's the servo at on here?
It's at the bottom in the middle, under drive.
Yeah, so this doesn't really, that's a problem with my, oh, there it is. Yeah, I think it said the 12 volts coming in. So into the, the physical box, that's the servo is, doopy, didn't mean to do that. I have a positive and negative represented by one line coming in here and a USB line coming in here. On this positive and negative, obviously just on the positive, there's also a fuse. Up here, if I just, if I, let's see, how did I do that? If I disconnect all of this, so nothing is drawing from here, and then put a voltmeter, I guess right there, get 0.5 volt. But if I take the fuse out, then I get 0 volts. So I think what I'm trying to say is, I think there's a 0.5 volt going down this line when I don't want it to. It's really the clumsy way of saying, I think I got something screwed up.
Is that with your Arduino powered up, or is that the Arduino's powered down since you pulled the main cable out?
Yeah, the Teensy wouldn't be powered because the USB wouldn't have any, I mean, I guess there could be some capacitor somewhere in there, but there's no supply power coming in. It would only be, say, a capacitor, maybe, that's draining, I guess, possibly.
Just in general, you might have a problem with your Teensy and your super servo. It says you've got 5 volts coming out of the super servo to power your Teensy, but you also have 5 volts coming in on the USB to power the thing. And you'd have to pull up the circuit diagram to see how that's wired up, but you may have to put a diode between your super servo and your Teensy, so you're not blatantly connecting the two together. Or like I was telling Doug, you can just pull off the jumper on the super servo, so you're only powering it from the USB cable coming in.
Yeah, I am blatantly I think I have blatantly connected, if this diagram is correct, and I believe it is, I blatantly connected 5 volts to this Teensy. And the reason for that is I always want that to be running. I always want this to have power back because I always want it to be generating that neutral position. I don't know if you remember or not, but these things, this servo will go to 0, and that's full reverse. If I don't know what the right language is, but I always want this to be powered is the bottom line for safety reasons. So a diode, let's see, where might I want a diode?
That line that says 5 volts, it's got an arrow pointed to the teensy. If you put a diode between the super servo and the teensy. Because otherwise, when your USB is plugged in, the teensy is being powered by that. And I believe the 5-volt pin on the teensy is just connected directly to that, which means when you plug in your USB cable, it's trying to power your super servo, which they're both going to be at approximately 5 volts when they're both powered up, but they're not going to be exactly the same. So if you put a diode in there, then whenever you got the super servos powered up, it will power the teensy. And I believe the USB side already has a diode built into it. But we'd have to pull up the circuit diagram for that and see.
Yeah. Well, I stomped all over Matt's. Matt, you had the floor. Sorry.
No. Just like we talked about last weekend or last week, I just put a relay in between the power side of that super servo. I think what Jeff was saying is that the way that you have yours wired up, if your servo is directly connected to that battery, it's generating 5 volts. So your teensy may be on all the time. And the way that I avoided that was to put a relay on the power side of that servo.
A relay on the power side of the servo. So
You can pull up your diagram.
yeah, how do you though accomplish the safety feature of, whether ROS is running or not, you want that teensy generating a neutral PWM signal?
That's true, but let's just consider the off position when the vehicle is powered down. When your vehicle is powered down, if it is wired this way, your servo is getting 12 volts from your battery.
Yeah, you're right. That's a problem. That's bad.
And if your servo is getting 12 volts from your battery, then it is generating a 5-volt signal to your teensy.
Yeah, and the only way to stop that is to pull the fuse in my current.
Right. So instead of me physically pulling a fuse, I just put a relay on that line, and then I can control it electronically. So in my startup sequence, if I start the robot up and I don't turn on that relay, then no power is being sent to the servo. And then as soon as I send the signal to the relay to turn on, then power is sent to the servo. And once the power is to the servo, then I've got a nano, but then your microcontroller has power.
And that requires ROS to be running to fire that relay, or doesn't?
Yes, I use ROS to, I use the service call to fire that relay.
And all that happens fast enough before this thing decides to jam it in reverse.
Well, here's the deal. My vehicle doesn't have the engine running at that point. So in my startup sequence, I power the electronics, everything comes up. And then when I want to start the vehicle, I send out another relay command, which hits the starter and then cranks the engine.
Okay, that makes sense. So it might be in reverse, but before you would ever start it, you get it out of reverse.
Yep.
Yeah, that's cool. That would be certainly a better design than what I've got. Anyway, like I said, I stole the floor and you were talking. What's going on in your world?
That's about it. Just working on the wiring, cleaning it up. My nice clean box looks like.
Ooh, show that back up again. You cut out for a second. That's the before or that's the after?
That's the current.
I was being a jerk.
So I take an iterative approach. I just wire it till it works and then go back through and clean it up. So now I'm on the cleanup phase.
Man, I don't know that. I don't. How do you debug that? I would go crazy, I think.
You have a diagram with all the pinouts in your notebook about what goes where. But definitely, I mean, the way you have it laid out, nice big box, that's the smart way to do it. You follow each line, you can see what's going on.
Well, mine takes up probably more space, and you've got your GPS thing mounted on top of your box, right? I mean, yours is very compact,
Yeah.
as I recall. So I'm not necessarily happy with mine, but it's getting me by. Jeff, anything you want to share? Maybe you already spoke while I was running late.
I was just trying to pull up a schematic for the Teensy here, and it's not obvious, so maybe I'll look at it a little harder later. But yesterday I got bored, and so I pulled out my little automotive gyroscope that I bought one time and just wired it up to actually wired it up to this, which is a Arduino Nano. So I had a 5-volt A to D converter that gives me 10 bits of resolution. And then when I pulled up this thing and went to wire it up, it says plus V on there, and I pulled up the data sheet for it. I assumed that you're running off 5 volts, but it turns out they say run it on 8 to 15 volts. So apparently it's made for, being automotive, they expect you, I assume they expect you hooked into your electrical system. And on one hand, that's good, because that means they've got a well-designed power supply inside. You give it some voltage and it gives you a nice clean signal, but it's bad because I can't run it off my Arduino, which puts out 5 volts. So I went ahead and wired it up, and I just wanted to find out, the basic thing is to see how much baseline drift I get, which means if you sit it on the table and it says it's moving at 0 speed, all the little cheap ones, just over time, that number will start drifting one way or the other, and that'll screw things up. So I hooked it up and ran it for about an hour, and it maybe I can even find a plot of it here. Documents. But it seemed to be that it was running at like 526 was the main number, and it would bounce up and down like one count, and it pretty much stayed that way for like an hour or so. So I was just as an initial test, I was fairly happy with that.
526, I don't understand. What is that number?
Out of your A to D input, it goes 0 to 1023 since I have a 10-bit converter. And here I finally got it pulled up here. Share screen, this one. So this is this actually is 546, I see. So it pretty much comes along this line, and over time it would either give me a 547 or a 545. So it's bouncing up and down by one count. And some of the little cheap ones, when you run it, that'll be, that line will drift up and down quite a ways. And I did some experiments one time where I just had a little cheap, like the MPU 9250, and I had it hooked up to a board, and I'd lay it on my kitchen counter and start doing this, where it'd start giving me the the value of it. So, you know, I'd start off at 0 and I'd jump up to whatever the number was. Then I'd pick it up, put it in my freezer in my kitchen, and you could watch as the temperature went down. You can see the baseline would also go down quite a ways. So at least the little cheap ones are seriously affected by temperature. And this one, I haven't tried putting it in my freezer or anything yet. It was just laying on the table. I just turned it on and walked away from it. But that's the first thing I want to know is how stable it is like that over time. And the next thing I gotta do is if I've got up to say any of the ARM parts, they'll give me a 12-bit converter. So now my zero goes from 0 to, or my number goes from 0 to 4095. And then if the Teensy, which has the 16-bit converter, I have to get a library to run it. Then I can go from 0 to 65, 535. So I get the 12-bit gives me 4 times the resolution, and the 16-bit gives me 16 times more resolution. And then what's going to happen then is I'll see a lot more of this, you know, this is bouncing up and down by plus or minus 1 count. And then when I go to the higher resolution, it'll be, you know, various counts. And then the question is it, I assume since this goes from 546 up to 547, that means that the voltage has crossed whatever this halfway point is, and that's why it switches. So then basically when I get the higher resolution, it'll be something closer down to hopefully closer to the number that I've got. So anyway, that's just something that I've been playing with, and so now it's a matter of going on to figuring out how I can give this thing the 12 volts that it wants to run, and then get a Teensy hooked up, and then try to figure out the A to D on that. And then from there, it does indeed work if I just put it on the table, and it's got the little thing on the side here where it shows so it has to go like this. They say it's pointed up like this, and then it rotates around like this. So it's just a matter of I'll have to figure out how to mount it on there, because I'm going to try to measure the yaw of the vehicle. So I'll try to mount it like that. And if I put it on the table and turn it, I think it says it's like plus or minus 100 degrees per second. So if I try to use it on like a differential drive vehicle or a skid steer vehicle that can turn in place, that's probably going to turn too fast. But on like an Ackerman drive vehicle, you know, it's hard to turn that fast. So it should work for that. So it's just a matter of I'm going to have to bolt it on something and try it out and see what kind of results I get out of it. Or I might go back to my concept where I'm going to hook up several of these at once. So I'll have this one, and I've got that EM 8070 or whatever, that the same one that Matt has. I got one of those, and I bought one of those Bosch like BN 055s or whatever they are, which I got those. I took it out of the box and looked at it. That's all far I got with that. And I've got the little SparkFun parts, so I can put all those on the same board and run them in the same thing, into the same processor, and then compare all the results out to see how they act, and then check it based on temperature, and then put it on the vehicle to see if I turn back and forth, does it actually track like it's supposed to. So that's just something. If I get around to it, I'll try these things and see what they do.
I mean, you're not going to buy
Other
the
than that,
fiber optic deal?
You know, I thought I should buy the one they say was broken, because they got one for like $50 or $30 or something. You still have to pay $20 shipping on it, but it would have all the pieces inside that you need. But it could be you take the cover off, it's all potted, so you can't get to anything. So if they say they have one that doesn't work, or it's for parts, it could be that the laser diode is burnt out, or it could be just something loose inside of it. But I didn't know if I want to get that, because it might just be a brick. You know, it turned out being a brick and not do anything with it. And if I wanted to pay the $400 for ones they say work, but I don't have any documentation on it, could be if I just send them something and say, tell me how to wire this up. They might have something that they could supply, but I decided I didn't want to do that. So, and I noticed on eBay they have other fiber optic gyros for sale, but again, I couldn't find any documentation for them, so I didn't want to go down that path. I think for a moment I'll play with this one and see what it does.
It was fascinating. I'd never heard anything about it, but after you sent that thing, I looked at it a while. I'm like, holy cow, pretty interesting.
Other than that, I guess
Jeff,
that's all I got for the moment.
that gyro looks pretty stable. What's the model number on that one?
Well, before I tell you what the model number is, don't run out and buy one of these just because I showed it. But let's see, where's the...
You're not done testing it yet?
Yeah, so I don't know if it's going to work at all. So don't rush right out and buy one. But um, I originally bought it on eBay, and I went back and thought, well, what did I pay for this? I was thinking I didn't pay much for it, but I looked, I paid $75 for this thing. So apparently I had a job at the time when I did that. And now there's a guy on eBay that's always been selling. He wants $91 a piece for them. And I was going to try to pull it up here so you can see what they look like. Rather than pull up the eBay ad, let me pull up the see if I can find a data sheet here. So move on to something else, and I'll go ahead and track this down and post this.
Matt, anything else on your list? Jonathan?
Doug's gyroscope reminds me of my friend built a gyroscope. So it's very similar to Doug's one, but bigger and more metal. And his idea was to make a slug zapping laser. So he spent a lot of time walking up and down inside polytunnels with scissors, snipping slugs. And he thought if he could get a neural net to be able to visually identify slugs, and get a gyroscope with a laser on, then maybe a little remote control car could just drive up and down the polytunnels, prying them. Yeah, I can maybe get a picture of it.
You could put a propeller on your front of your robot car and drive it down. That way the propeller can just slice them up.
A propeller.
I was trying to think of something that would slice them up.
I think a laser would be the easiest.
Yeah.
Just mechanically, it's much easier, just to point a laser at it. Yeah.
Yeah, you could autocorrect by having the laser fire, and then on your image that's recognizing the slug, just bring them together.
Yeah.
I was just doing a search to see if I think all cars, most cars anyway, these days have a gyroscope in them, to see if anybody mentions who the part manufacturer is.
So I posted a link there to a data sheet. And I don't even know how old these things are. I don't know if there's a date on it, or maybe the data sheet would say. This probably isn't the modern stuff that they use. They probably gone to the little MEMS gyroscopes these days, but I don't know. This is they say it's a crystal tuning fork, I think is what they say it is. So it's not like the original MEMS or the MEMS stuff they use now. And that's the whole reason I bought it. It was a different technology. And I figured, well, if they're doing it for the automotive industry, it's probably built a lot better than buying something, a little thing on eBay from China. So it's just another thing to experiment with.
Now here's an interesting link.
There you are.
So the motorcycle guys want the self-balancing, to make a self-balancing motorcycle.
Actually, the wheels on a bike or motorcycle actually do provide some balancing effect, as I understand itself. I was putting one. Wonder if how if we could how far you can correct. You just have your bike. You think just sit there and get off it, and it'll stay upright.
Can't tell you, haven't, I just stumbled across that. Jeff, are you good?
Yeah, I guess so.
Matt, you good?
Yeah.
Jonathan?
Yeah.
Doug? You're on
15
mute.
minutes early.
Say that again, Jonathan.
We're 15 minutes early. Everyone can get their Friday night. Oh no, you're in the middle of the day, aren't you?
We can start early.
Yeah. I've got my colleague's 60th birthday is today, so I'm about to go and get onto the beer and pizza.
And are the pubs closed?
Yeah, we've got a wood-fired pizza oven on the farm though. So
Oh, that's cool.
someone's got the pizza oven going, and we've got a big box of beers and all his family around, and yeah, so that's my weekend written off.
That sounds awesome.
I will make some more comments on this gyroscope that I've got. This is a single axis gyroscope. So it means that to use it in the real world, what I should do is have, I can take one of the cheap ones, which gives me pitch and roll, and those are compensated by the accelerometers. It's just that for the yaw gyroscope, the only way to compensate for those is to use a magnetometer. And so that's why I want to find something that's more calm than the cheap little ones that you get. So hopefully this one, you know, if I got this one turning like this, it's going to be more stable and not drift as much. And then I can use the pitch and roll from the cheap ones to give me full 3D to make the thing work. So it's still going to be a lot of playing around, even if this works better than a MEMS gyroscope. I still have to figure out how to integrate that in. And back in the old days, before I started playing with Ross, I did a lot of playing around with gyroscopes, and I had a Melexis. It was like a 96066 or something. I don't remember what it was. And I think it had a built-in 10-bit A to D converter, but I'd put it on my robots and drive it across the yard, and you'd have to play with it to get it corrected. But, you know, I'd drive from point A to point B, and the odometry says, yep, you're going exactly straight, although the gyroscope would be, you know, the gyroscope would curve off at an angle like this, which, you know, that's the real value of what it was doing. So there's a lot you can do with the gyroscope. You know, once you get to the Ross world, they say, oh yeah, you just take it, and whatever signal is putting out, you feed it into a Kalman filter, and that cleans it all up, and everybody's happy. Well, it turns out if you get a better signal to start with, you're better off. So that's kind of I want to get back to that and try to figure out how to get the baseline or the basic stuff to work. And back to my story about where I put my gyroscope in the freezer, and you can see that I had it so you could read the temperature right out of that MPU 9250 chip as just an A to D count. So you could see what's sitting on the counter would be about halfway in between, showing room temperature. And then I put another external temperature sensor on that so I could read the ambient temperature. And I was reading out the baseline, the actual gyroscope rotation value. And you'd sit it on the counter for a while, let all those stabilize, and you throw it in the freezer. And you could immediately see the ambient temperature would drop down to like 0 degrees F or 5 degrees, 5 degrees, whatever my freezer was. And then the one in the gyroscope itself would change slower because there's mass of the gyroscope. And as it would do that, you could see the baseline, the zero value would drift off quite a bit. So then I thought, okay, now I know what's going on. So I took my little gyroscope chip and made a heater for it. So I just had like 4 or 5 100 ohm resistors soldered together in parallel and stuck to that to the back of the board. And then I cut a foam block to put the thing inside, like a styrofoam block. It's like house insulation. We cut a little pocket to put the thing in there. So I just had an external transistor, a big transistor. So my little Arduino board would create a PWM value to run those resistors and make them heat up. And then by reading the temperature out of the gyroscope, you got a reference. So now I'd run it on the counter and let everything stabilize. I stick it in the freezer, and you can see the ambient temperature again would drop to like 5 degrees Fahrenheit, but the inside of the chip would stay the fairly close. I think I could hold it within like half a degree Fahrenheit for the temperature. And also when I was doing that, I could plot out the PWM value. So as I throw it in the freezer, you can see the PWM value would come up, and then it would hold the temperature constant. I was getting real close to the max PWM, so either need to put a higher voltage on those resistors, or put a couple more in parallel to generate more heat or something. So that's yet another thing you can do. This goes back to the old days where the ham radio guys built what they called a crystal oven. So they wanted precise oscillators, so they'd get a block of styrofoam and put their crystal and a thermistor. I think they actually glue the thermistor to the crystal can, and then you just put power on it. If you get the right kind of thermistor, there's a positive temperature coefficient and a negative temperature coefficient. I don't remember which is which, but basically you hook the thermistor right across like a 12-volt power supply, and the thing would heat up to a certain point, and then it would just automatically hold that temperature. So that's what they would do. They put it inside there, and that would hold a constant temperature on the crystals. That's what inspired me to do this. So I played with that a long time ago, and somewhere I've got plots, but they're on 2 or 3 computers ago, so I'd have to pull them up to find all that stuff. So there's all kinds of little tricks you can do to make this stuff work better. So again, it's just a matter of experimenting and see what works and what doesn't work.
Fascinating to me.
It always comes back to the story. Somebody says, oh, you just hook it up, and no matter what signal's put out, you just take care of it mathematically. They, well, yeah, but if it just worked right to start with, you wouldn't have to go to all that extra trouble either. So I guess the only other comment I can make is our robot meeting that we have once a month, the makerspace is shut down because of the COVID, and they have a system now where you can request a 3-hour window so you can go in and work on your projects. But basically the classroom wasn't open, so we didn't have our meetings there. And then somewhere along the line, they switched over to a new system that this whole ordering system and your subscription to set up your membership and everything. And they told me to sign up for that, and I couldn't get into it. And with a little haggling back and forth, it turns out, well, I can't sign in because my membership is expired. The only way to access it is to renew for another month. And I wasn't going to do that, so I told them I was done, at which I pretty much got to the point where I wasn't using it anyway, and I had to pay for it every month. So I finally decided to bail on that. And then having to open the door every day or every month for 20 years, I finally got tired of doing that. So I said, I'm done with it. We're going to cancel the meetings there. And then Cam, one of the people that was involved in the meetup groups, decided to set up a Zoom meeting. So we had our first Zoom meeting last night. So we went for like 2 hours of people just talking about whatever they're doing. And so that's yet another thing that we can get together and talk on. And I think what do we have? I think we had 8 people, and a couple of people dropped on and off. I think we had, at least most of the time, we had 8 people talking, and we just going on about whatever. So, and this brings up people from the past, where we had one guy from Boston who started the whole group. He moved out to Boston. He was on there. And then several people that, 1 or 2 people that have been there a long time ago, and now they don't come to meetings anymore. But all of a sudden, everybody popped up on the Zoom meeting. So it was interesting to do that.
We had twice as many people as we normally had, I think.
Yeah, probably. It got to the point where we just had just a handful of people would show up every month. And, and part of the people don't really care about robots, but they just want to come hang out with a bunch of nerds. So that's just the way, that's kind of where meetings devolved into. And so we'll see what happens here. And on this first meeting, one guy said, well, he forgot about it. He logged in about halfway through. So it could be by next month more people will know about it. And so that's
I started trying to watch.
What's that?
I figured I didn't want to ask stupid questions that you guys have already explained in great detail in previous meetings. So I started trying to watch through the back catalogue of all of your ROS meetings. There were quite a few different people a year ago.
Yeah, people seem to come and go, and they'll join and they'll stay for a couple of meetings, and some people will stay for a long time and then move on. So a lot of people still follow the Slack channel, so, and they may or may not go watch the old videos. I don't know. I don't know how many people actually do that.
Can't kill off some of us, Jonathan.
Say again?
Can't get rid of some of us, though.
I think I'm going to be hard to shift.
Good. That's the kind we like. As solid as that rock in Jeff's backyard.
The moon and Jeff. Cool. See you all next week, everyone.
Bye, guys. Have a good
Okay.
weekend.
Have a good weekend.